Welcome everybody to our webinar today, Actiflo Operation 101. I can see that there are still a few people that are in the process of logging on here right at 2 o'clock. So we're going to give it another minute or so, and then we will start momentarily. Thanks for your patience. Okay, welcome everybody to today's webinar. My name is Jill Browning, and I will be your moderator for today's webinar on Actiflo Operation 101, Understanding Basics and Optimization Scenarios. Before we get into the presentation today, just a few housekeeping slides. First of all, you should hopefully be hearing me speak right now. But I do want to mention that there are two different audio options to connect. You can either connect through your computer or there is a dedicated phone line as well. So if for some reason one of those audio options quits working throughout the webinar today, feel free to switch to the other one. One other thing to note is because of the large number of participants today on the line, we have gone ahead and muted everybody's lines. But don't worry, we do still have an option for you to interact with our panelists today. There is a questions panel over on the right side of your screen. So any questions that pop into your mind throughout today's presentation, feel free to go ahead and type those up for us, and then we do have some time set aside at the end of the presentation today to hopefully get through as many of those questions as possible. Do want to note we're in the process of conducting a 4-week live webinar series. A few of the webinars are up on the screen right now. You can go to www.veoliawatertech.com to take a look at those that are available, and we do have some that are available in French as well as English. Additionally, we have gone through our arsenal and put up over 40 webinars that we've conducted over the last couple of years and placed those on our website as well, available for you on demand. So feel free to check those out, and if any of those are of interest, feel free to register and watch those at your convenience as well. Those are available over at that same website, www.veoliawatertech.com. We are offering a participation certificate. You'll receive that automatically within probably 24 hours. So if that is something of interest for you, be on the lookout for that, and you'll receive that hopefully tomorrow. And finally, we do ask that you participate in our survey at the end of today's webinar. It's a short survey, hopefully it should take you no more than 30 or 40 seconds. We do value your feedback on that, as well as potential webinar topics for the future that may be of interest for you. And for those of you that do complete that, we are offering the chance to enter a raffle for a $25 Amazon gift card. So if you are selected for that as the winner, we'll be following up with you within the next day or so. Okay, one last slide before I turn it over and introduce our speakers for today's presentation. Veolia Water Technologies, we are a leading company within water treatment. We focus our efforts within 3 key main areas. First one, technologies. We offer advanced and robust water treatment technologies. We have over a large portfolio of over 350 proprietary technologies that we're able to offer to our clients. In addition to our technologies, we're able to pair those technologies in terms of developing projects for customers and also put multiple technologies together to meet the required treatment specifications of the client. And then lastly, we do have a very thorough service offering that we can offer. So with that, I am going to introduce our speakers today. First speaker will be Brian Fincher. Brian has been with Veolia for over 11 years, working on a variety of water and wastewater treatment projects. His first years in the industry were spent as a pilot and process engineer testing and demonstrating the validity of various treatment systems for full-scale implementation, including Actiflo and Hydrotech filters. He is currently the process group manager for Veolia Water Technologies Municipal Office in the US, overseeing their clarification and separations treatment technologies. Our second speaker will be Ryan Cawley. Ryan is a service technician who has over 8 years of experience commissioning and optimizing Actiflo. He has worked with Veolia's Canadian office since 2014 and previously worked for Veolia in the US before that. Ryan works on startups, upgrades, and preventative maintenance on units all over Canada. And then finally, our last speaker of the day will be Mark Drake. Mark has been a water professional for over 20 years. He obtained his BS in chemical engineering with an environmental emphasis from Iowa State University. Mark has held PE designations within Wisconsin and North Carolina, and became a lead accredited professional in 2008. Mark has been part of Veolia Water Technologies US Municipal team since 2010 as the product manager for biological products, and as a product champion for Aquavista line of digital solutions. So with that, all of that, I'd just like to introduce, so we've got Brian that'll be talking a little bit about the Actiflo background today, and then turn it over to Ryan to talk more about water chemistry basics, Actiflo operation, as well as some troubleshooting. And then finally, we'll round it out with Mark Drake on Aquavista remote support before opening that up to a Q&A. So with that, I will turn it over to Brian.
All right, thanks, Jill. So today I'll be talking a little bit about the Actiflo background and family, and just going over a few different types of Actiflos that we have and offer. So just a brief overview of the Actiflo systems and the different variations and markets that we serve. In the industrial market, installations we have include treatment at power plants, mining sites, as well as food and beverage facilities, and the oil and gas industry. On the municipal side, Actiflo is used as pre-treatment in drinking water facilities, mainly for turbidity and color removal, and wastewater treatment plants, treating excess wet weather streams, as well as used for polishing effluent total phosphorus at these plants. So how does Actiflo work? Actiflo is a high-rate ballasted system that uses microsand as ballast for rapid settling of flocks and solids, resulting in a quick startup time and small footprint compared to conventional clarifiers. There are basically 5 main components to the system. First, a coagulant, which is typically an iron or aluminum base metal salt, is added to the raw water stream before entering the coagulation tank. Here, the coagulant destabilizes particles and colloidal matter to begin forming the hydroxide flocks. As flow leaves the coagulation tank, it moves on into the maturation or flocculation tank, where polymer is added to enhance the size of the flocks and attach them to the microsand ballast. As the flocks leave the maturation tank, they enter the settling or clarification zone, where the sand and sludge settle to the bottom and the clarified water upflows through lamella plates or tubes and exits the system by flowing out through the effluent troughs. A sludge scraper collects the settled flocks at the bottom of the settling tank into a pit. Microsand recirculation pumps will draw the sand slurry mixture from the pit and pump it to the hydrocyclones, where the sand and sludge are separated by centrifugal forces. The sludge will then exit the top of the cyclone, and the clean microsand is recycled back to the maturation tank for reuse. Actiflo timeline. The Actiflo was not developed overnight, and as you can see, the first version of Actiflo was developed around 1988, and over the years has continued to develop. It has also evolved into more specific areas to meet different needs, and I'll go over a couple of different iterations you see highlighted here. Worldwide, there are over 1,100 Actiflo installations, and well over a third of those are just in North America. There are over 250 installations in the US, with half of those being drinking water facilities. And in Canada, there are over 200 installations with 110 that are used for drinking water. One of the iterations that we mentioned earlier was Actiflo for softening. And Actiflo Soft is used for hardness and alkalinity removal, both in municipal and industrial applications. This is achieved through the addition of lime or caustic or soda ash, and it's used for precipitating out calcium magnesium hardness. Precipitation tank is added at the front end of the Actiflo to accomplish this, and the precipitation tank can have up to 20 minutes of contact time depending on how much hardness is truly needed to be removed. Actiflo for wet weather. On the wastewater side of things, Actiflo can be used for treating excess flows into a plant, typically CSO, SSO treatment. It can achieve high removals of TSS and particulate BOD. With the addition of a biological contact tank upstream of the Actiflo and the addition of RAS or WAS in that contact tank, which you can achieve higher BOD, total BOD removals through soluble BOD uptake in that contact tank, and thus you could achieve upwards of 85% removal of total BOD through that system. In addition to the wet weather treatment, the Actiflo can also double as a dual use for tertiary treatment and polishing phosphorus down to levels of 0.075 milligrams per liter. And then final iteration we'll talk about is the Actiflo carb. And Actiflo carb is typically used for high organic treatment, MIB, geosmin, pharmaceuticals, endocrine disruptors, and even PFAS compounds. Actiflo carb utilizes powder activated carbon and its absorption capabilities to remove the organics with roughly a 5 to 10 minute packed pre-contact tank ahead of the Actiflo system. The organic removal can typically be achieved upwards of 65% removal, and really depends on how much organics you have coming in, and can also help with disinfection byproducts throughout the distribution system. So with that, I'll turn it over to Ryan, and he'll go into a lot more detail and with water chemistry as well as the Actiflo operation and troubleshooting.
Right, thank you, Brian. Thank you, Jill. So the water chemistry of the Actiflo is really the foundation on which a lot of the things are built. So I'm going to go over a few points. The purpose of the coagulation is really to convert the dissolved substances in the colloidal particles and start to destabilize them so that the agglomeration and ultimately the settling is eased. The first half of the coagulation leads swiftly to the flocculation half of that backbone, and flocculation is where those particles really become dense thanks to the ballast of the microsand. So you can see a picture that I've inserted here taken from the maturation chamber, where Brian kind of said that those the magic really starts to happen. You could see the light kind of kernels of those flock start to form, and more importantly, that darker interstitial water in between the two. So you really, it becomes apparent here that we've got some good process happening, and this is kind of what you want to see. The getting back into the coagulation a bit, as Brian stated, the metal salts that we use for coagulant are typically iron and aluminum based, and that difference between the two really establishes where in your pH range you want to be, and obviously the fluctuations in your raw water are going to drive that one way or the other, whether it's just your hydrology or if you have pH adjustment somewhere along the way. There are typical ranges that you might need either pH adjustment or alkalinity addition, or both, to really affect to get a final hydrolysis of those coagulants. But the choice of what you have in raw water, as well as obviously availability of the market and what other treatment chains you have, affects your decision here. And it is possible to switch, so we'll get to that a little bit later. So why you need this coagulation, I'm going to just focus on two real sides. You could see this picture on the treatment of turbidity of the raw water kind of separating out to become clarified water and leaving this type of sludge inside. It's whatever suspended particle or soluble particle has been precipitated out. And but conversely, the color is something that's much smaller particle, harder to settle, but though the negative charge of the organic particles and that make up the color, or tannins or what have you, are easily prone to coagulation, and it's a nice clear water that you can end up with, and a very apparent darker sludge that drives those. But as your turbidity and color, or TDS, increase or decrease, whatever, seasonal or weather driven, it's going to affect the range of the pH as well. So keep that in mind with the coagulation check, and adding more coagulant for the more turbidity or what have you is going to also most likely drive the pH and depress the pH. So good choice of chemical there. It's important. The raw water primary particles, whatever makes up those turbidity, TDS, color, is going to be first destabilized by the coagulant and form those nice flock, and then ultimately get to the hydroxide flock, which does get a coat of polymer, but more important than that is to get a nice fresh coat of polymer on the microsand as well, to begin a good seed for the agglomeration of a nice, heavy, high density ballast. And this is just an illustration of really a very reductionist flow path, process path, to kind of give you an idea of what Brian was talking about earlier. And so whenever we get to the Actiflo operation segment of things, you can kind of picture what's happening whenever I show you this. This is the flow path of treatment chain, just a different angle from which Brian was talking. So you can see where the coagulant is dosed, ideally further upstream to get some good contact time, and far before this coagulation chamber. And we have an underflow to either a injection chamber or just a one flocculation chamber, where they start to marry with the as I said, a good coat on the outside of that sand that you're either adding through new bags or more regularly the micro sand that is being added through the underflow of your hydrocyclone it's getting a nice maturation, an easy mix through your mixer and draft tube to form those large popcorn flock before they overflow to the underflow of the siphonal wall, and which the clarified water will impact that or come in contact with the lamella pack before it overflows to the clear well as a form of the clarified water. This hydrology or the hydraulics, as well as the chemical treatment, is what makes the Actiflo go, as well as recapturing what is essentially waste, the sand and sludge, into that sludge loop before using that centrifugal force, the hydrocyclone, to scrub the sludge and recycle the nice fresh sand for the retention of that sand that you had bought however many months before. Whenever we do put this presentation up, there's a pretty good clip that go through. I don't know if someone requested in the Q&A I could play it, but 3 to 5 minutes is not, I don't think it's worth it right here, but hopefully you can use that. So as Brian said, the footprint of our Actiflo is one of the big selling points of this. If you use a big ring classical clarifier, it can be as much of a comparison, if I can use an analogy, to a football field to a boxing ring that the Actiflo will take up. And not to dive into those numbers too much, but the to combine those two techniques of the basoflocculation and the lamellar settling is what makes this reduction of size possible, footprint. But operating this as the best you can is getting a good understanding of what your equipment, your raw water parameters, and what potential changes might be coming down the pike. So I'd mentioned the coagulant polymer dosing, but I'll dig into those a bit further. The microsand concentration, there's a range here that we're always shooting for, because the liter, or I guess GPM, of the gallons of the denominator are going to change from minute to minute, second to second, as your actual flow increases or decreases. And the reason I have actual flow versus design is because I have found time after time that the Actiflo likes to run on the higher range. You have more static mixing, more easy, gentle maturation time, natural mixing of the primary particles with the coagulant and polymer, just to as compared to a mixer, which can shear the particles, especially if you're dealing with a anionic flock or something that is a little bit more fragile flock formed. But there's also a minimum flow, even if you're not just trying to crank one to get a good process chemistry. Whenever you see the flow at the troughs kind of start to pulsate, it means that you're taking a much larger proportion of your throughput through the centrifugal pump of the sludge loop that you really should be getting whenever they thought about it in design. It's affecting the settling velocity and the flow and the rise rate. So you don't want like a chugging or an erratic flow going into your lamella. If you can, then then is the time to combine your trains into one or less Actiflo, because that'll help you in a few different fronts. So getting to know all of those basic parameters, you build this yourself, other than all the training we're obviously here to help you out with, we want you to start looking at things on a few different graduated basis. Obviously, the operators make their rounds of those raw water and clarified water characteristics that I mentioned before, as well as please visual inspection of the hydrocyclone, because that is that's what's introducing your microsand reagent. And a very quick blockage or something can lead to either a large loss in sand or the cycling up of sludge. Compared to in every shift, not as much of a priority. I'll talk more about these in the troubleshooting, and of course, if any of these strike an interest, your Q&A, I'm more than happy to talk about any of it. But I've already gone over some things like the microsand. I'll go into in 2 slides, but the alkalinity, which is needed for the hydrolysis of your coagulant, and why pH is important. But the very next slides will be the coagulant and polymer, how you can verify that. Compared to the daily tests, which are some of the more getting into more mechanical, as well as lab and bench scale verification of your process, making sure that everything, all of your KPIs are checked, and that you're not perhaps overdosing coagulant. On a weekly basis, just making sure that you're really prepared for an eventuality, more like preventative maintenance sort of thing, but checking the flow rates from the underflow and overflow of the hydrocyclone will help to diagnose and know that where what is going. So whenever you're starting to respond to something with those, with all that data that you've collected, you don't always have control of your inner water turbidity. There's always EQ tanks and things like that where you can kind of buffer, but we're going to go ahead and assume that things like the flow, turbidity, color are not what you can impact, but you can impact how much or how little, or the quality of your reagent. Hopefully you have some sort of way to raise the pH if you can adjust, or conversely, not as much coagulant will help to raise that. But your microsand addition, or just making sure that you have a good clean microsand, because you can wear it down. You have nice fissures in there, almost like the activated carbon image that Brian had showed you. Microsand can be polished and buffed, and a lot of those fines will start to float out through your clarified effluent, and you'll be left with a sand that isn't quite as good at ballasting, or might need more polymer to grab onto that flock that you would form. Sludge extraction through either a hydrocyclone that isn't acting properly, or perhaps a pump that isn't sized for your flow or your loading of solids. Compared to also lamella cleaning, something that noticing how more and more plants, if the frequency of this will help to keep the solids from building up, and then the ease of that load fluffing off of the lamella into the clarified effluent. But the knowledge of how much sand you have, and why you need to have a range in there to allow for the fluctuations in flow or characteristic of your water. It can not only maybe be a little bit higher than you think you need if you have a nice low turbidity, but make sure that you're grabbing it a representative sample as well. You take it once, you assume it's fine. It's been the same for a week. Maybe you don't need to do it 3 or 4 times, but you don't realize that the time that you grabbed it, say the rake hadn't been going through, it had been going through a bare spot, and not, for some reason, the sludge is all settling into a snowdrift on the opposite end of the dial. So if you are taking it from the same hydrocyclone, maybe if a minute or a minute and a half later, you could get a different sample. But anyway, you want to take a representative, a good amount to get a representative sample, so you can average out those two numbers in this calculation. The volume of your microsand selection, as well as the amount of sand that's in it when you add in the flow rate, is going to give you the number that we quoted before. And it's going to be different for a lot of different plants. So if your specific application, you have questions about this, I'd be more than happy to talk about it either in Q&A, or when you fill out that survey to get a good gift card later on, we can talk about it then too. And but just know that if you're adding half a bag or a bag of sand a day, it isn't uncommon, because when you're losing that sand through attrition, like I said, you're breaking up that activated or activated sand to and polish it up, you're losing those fines. And that's why the quality of your sand matters. We obviously have our Hydrex sand, micro sand, but if you decide to try just say a beach sand or a kiddie playpen sand, you will not see a comparable thing. Not only will the clarified effluent have a lot of impurities in it, but you're not going to ballast the same way. So regardless of what you're using, know that there's a specific granulometry, and there is a range in there for a larger or smaller micron size, even within our Hydrex. But we'll be happy to talk about that if there are any questions. Why your hydrocyclone is important? You want to keep an eye on not only your inlet pressure to make sure that there is no blockage, or that apex here at the bottom that is driving a lot of your pressure isn't being worn out, but also it helps to identify if you're having perhaps a clog or a wearing pump. It can tell you a few different things about your process, can your hydrocyclone and your microsand sample, which is why I've lumped these together. And I'll get to more about the troubleshooting section, but just know that this is kind of what it looks like inside the centrifugal forces, and you want to keep your good clean sand going down and your light sludge going to the overflow. And there are typically 3 different components in here: the inlet, the apex, and the vortex finder that do wear, and the apex being by far the heaviest wear point. But before we get into any troubleshooting, I do want to emphasize the safety, rotating equipment, energized equipment, not to mention chemicals, especially when you're adding bulk loads of sand. There is that the silicosis, and keeping the sand out of your lungs is important, whether you're just adding a few bags or you're doing maintenance down in a tank that had maturation, or a settling tank that had been empty for a while. It's trouble, so keep the safety first, please. But keeping a sight of your ultimate objective is paramount, because it can be very satisfying to see your turbidity or your color decrease with a nice slug increase of chemical, namely polymer. It's fun to see that happen, but what is happening downstream? Or if you're increasing your coagulant to try and destabilize some particles, it may work, but what is your pH, and are you going to end up with aluminum or ferric iron in your effluent clarified? So keep those things in mind, why you're troubleshooting to begin with. And just below that is documentation. Make sure you're recording what you're doing so that you can use this for the future, be it a week later, whenever conditions either continue to get worse, or get better. So you can just walk back the changes you had made, or 12 months from now, whenever the spring melt happens once again. And yeah, you can be prepared, either having more sand ready inside, already in the tank, so you don't have to add a whole bunch at once and lose a whole whack of it because you've added 2,000 kilos of sand. And but just again, there's the safety that is underlying all of this, whether you're Veolia people or consultants or just watching from afar. So I have a few decision flow charts that I have on our main 5 or 6 incidences within Actiflo, but the main thing I want to do is that these are the main incidences. And clarified effluent turbidity is the most common thing they get. So I wanted to put up a few different items, and what you will see me coming back to time and time again is verifying your hydrocyclone and verifying your chemistry. And if you can keep everything running smooth, you'll have to do these verifications less. However, you can also get into a rut. So I include these, not a rut. You can get into a habit of going back to the same things that work all the time. But if you have these things to reference, it can help you if you've just forgotten what had helped you 2 or 3 years ago, or what I talked about 5 years in the future. Likewise, the clarified color increase is so much more pH driven, but you can use these as well as the microsand concentration decrease, checking different points of the hydrocyclone, or carrying this over to what your pH has done to affect all of your other chemistry. And just know that we're here to guide you in your troubleshooting, as well as accept jar testing and doing lab analysis for you if you do need that kind of reset or revisiting of your troubleshooting efforts. And only one point for the chemical dosage inconsistency that I just see it so often, that especially with the coagulants that have not necessarily impurities, but just a heavier makeup to them, they gum up the underside of the pressure relief valves or your back pressure valves, and these can make an uneven space, and it's easy for the reagent to pass back into the day tank. So you're not dosing what you think, even though it's flowing through the pump. There are a few different items in here that I like, especially the checking your inputs into your HMI, making sure that the capacity of the pump is set in there, as well as injection quills. But yeah, please remember that these are here, is why I include them. Getting back to the hydrocyclone, just because it is just such an important aspect of your troubleshooting, a good cone discharge is something you identify visually if it's the type of hydrocyclone that isn't set right into the surface of the tank. Not only can you see this good medium level cone, but you can hear it frequently enough, especially if you're walking past hourly. But if there's an obstruction, or perhaps there was a mistake in ordering and the outlet of the apex tip is too small, it will rope, called that, or you could see the solids become uneven on one side or another. And it won't be just a nice homogeneous like fan shaped cone of a spray. That there's probably something stuck in it. It's unlikely that someone put in something that's that much smaller, but conversely, if someone has paid too little attention to the hydrocyclone and let it wear out, or installed one that's too large, it will put too little back pressure and more sludge will recycle through your system. charging up and up and up and cycling up, and you'll eventually have a perfect process, but keep building up your sludge blanket in your settling tank despite all your perfect efforts. And yeah, it's because your sludge isn't being evacuated out through the top of the vortex finder, and it's coming down through your worn apex tip. So as I do concentrate on the apex, there is those two other wear points. Just a general rule of thumb, if you've replaced two apex tips, it's probably time to look at either the inlet or the vortex finder, or both of those other two segments of your hydrocyclone for just to put a bug in your ear. So lamella cleaning is, like I mentioned before, whenever this polystyrene catches the solids in the sand that you're settling out time after time, whether you're building a sludge blanket or not, it's important to make sure that it's clean, because even if your process is perfect, just the velocity and the upflow of your water is going to carry out some of that buildup. And if you can keep that clean, it's going to not only save you from adding sand, but it's going to help your effluent. So in the end, a capital investment of an automatic air scour isn't the worst way to go if it saves you man hours and sand, and it saves whatever's downflow of your Actiflo, even if it's just a river or lake that has a buildup of dust or micro sand. It could be worth the investing, as well as checking out the quality of your polystyrene lamella pack every year, because it's not every year, but it's going to have a lifetime. So if it's been a couple of decades, please just pay attention. Those cracks aren't normal. And the recirculation pump, whereas it kind of gets ignored in a lot of my troubleshooting efforts, it is still a wear part. The gland, the impeller, and the lining are all points. And I include in here more than just reminding you that it's a wear part, but that if you are troubleshooting and you're using your proper lockout, tagout, and PPE, and you're doing your work, most Actiflo, it's going to trigger a fault shutdown. But if for some reason you're able to run it without it, run the treatment chain without a microsand pump in place, you're going to find very quickly that you've clogged that sludge loop. So there's a reason why that Actiflo shutdown sequence has the rake and the recirculation pump running for 5 minutes, and then stopping the rake and having the pump run even longer after that to get a nice light circulation loop through there. There's a reason for that. Lastly, not lastly, but next, there's the mixer. The orientation of your mixer pumping direction is important. So if you're doing electrical work, changing out a motor, and you're restarting it, the direction, verifying the polarity of your motor, as well as the direction of the pumping action of your mixer, is important. Not only because it will help to shear your flock less if it's in your injection chamber or your maturation chamber, but because it's going to affect that retention time that's so important, where what I was talking about, the water chemistry, all of those slides ago. Either you're going to short circuit, or you're going to cause too much precipitation in the sides of your tanks. The jar testing is somewhere that we're happy to help. It is a good last resort. If there's nothing else that you can do on the fly to help to troubleshoot, you've started your troubleshooting, you've looked through those chains, you've made one change, waited 15 minutes, made another change time after time, you still haven't gotten there. grabbing your raw water and going through a good step-by-step process to find out how to get good clarified water, comparing one concentration of coagulant, say, to another, or one type of polymer to another, is very helpful. And if that's not something you feel like you could do on site, it's something that we can do in our lab quite easily, as well as send you a report and analysis. So as we all know, the work from afar is more and more important. So whether you're just monitoring the system or being able to trust the values, the process values you're getting from your instrumentation, or if you're building in some sort of a feedback loop for your dosage of, say, coagulant based on the TSS of the raw water, having trust in your hardware and your firmware is paramount. So please know that we're here to help you, not just with the chemistry, mechanical, but also with the instrumentation, electrical, and more and more the automation. And really, with that note, I'll pass it over to actually pass over the spare parts that we recommend to keep in stock when you're doing any of this troubleshooting, and more the annual maintenance breakdown, some sort of a stoppage of work to inspect things and go over and look at your mixers. It's good to be prepared going into this with things to change out. So on the shelf, instruments, hydrocyclone parts, mixers, and dosing pump wear parts are great, as well as those PLC and IO card hardware. But now I will pass this off to Mark Drake so he can talk about some of that remote distance that I was talking about a second ago.
Very good. Thank you, Ryan. And thank you for not leaving me to talk about the spare parts. Not my strong suit, but I'm here today to talk a little bit about Aquavista. And Aquavista is simply, it's one of our trade names for the digital services and the remote support that we provide to our customers. And that extends beyond Actiflo customers, of course. But we have done a lot with some existing Actiflo customers with this type of service. And it might be something that some of you would find beneficial. So, as we all know, it takes a lot of expertise to run a plant. As Ryan just went through, there's a lot of information to pay attention to, and a lot of things to keep track of and tweak and adjust to optimize systems, to squeeze as much performance out of systems, to get the most energy efficient operation of a system, and to maintain those systems. We want you to know that we're here to help you in those processes that are necessary at your facility. And what we call our Aquavista Assist service contracts are one way that we do that. We cover a large range of functions with that, from being there kind of if you need it, holding your hand with process reviews, plant audits, offering reports to help you optimize your plant, to assisting with various types of maintenance things through things like FieldBit augmented reality tools. We've seen, especially now with the COVID situation, the need to be able to do things without having somebody present on site, or at least to be able to do that as much as possible. So we've really seen an increase in the use of things like the FieldBit augmented reality, and that lets one of our technicians see what you were seeing. You can see a little picture there, shows a guy with some glasses on The glasses aren't required. You can use your phone, a tablet, anything that has a camera on it that is a web-connected device and has a screen that you can see. Our technician can see what you're seeing and can send training information to you real time, can mark up the screen and kind of help walk through various procedures and processes to perform various functions at the plant. We've always been very willing and ready to help with troubleshooting and emergency support. We have a number of plants that have relied on our 24/7 support to help through a process situation or automation issues. And all of this, our goal is to improve your plant's reliability and make your operation as seamless as possible, keep you in compliance, and make your lives better. So today, one of the key ways that we do that is with our Aquavista portal. All of those services I mentioned, those are all things that we can support in various ways. And this is really becoming the predominant way that we can best support our customers. Aquavista portal is it's a cloud-based monitoring system that we provide. And it's not just applicable to the products and the technologies that we sell. Any piece of information, any piece of equipment, any particular unit operation at a water or wastewater facility, if the information is available through the PLC network, then we can utilize that information. And essentially what we do is we created a dashboard in the cloud that has a variety of different functions and features. But the primary benefit of that is it's there as a tool for us to help support you better. And we can see your data in real time. We can see historical trending. We don't have to exchange spreadsheets. We don't have to dial in through a VPN that might be dropping from time to time. It's all there. So that's the key function of that portal. It just makes it a lot easier for us to assist and to give you our expertise. So portal is cloud-based. If you're an existing facility and that's the direction you want to look in, essentially what it consists of is a very simple, inexpensive device we would come out and install in the PLC pan, one of the PLC panels at the plant, to say your Actiflo PLC control panel. And then we would configure that to pull the key pieces of information, your effluent turbidity, flow information, pH, all of those things that we want to look at and that you need to look at to best optimize and operate your system. So the portal provides trending of those variables, historical saving of those variables, a lot of the kind of functions that those of you who have a typical SCADA system at your plant, a lot of that kind of function, but really focused on typically on the key process stuff. But if we can go ahead and move to the next slide. We present that in a variety of ways with graphs and gauges, PFDs, so a lot of typical SCADA kind of stuff. But we also provide for all kinds of document storage. There are KPIs that will generate, that will allow, maybe not, as an operator, maybe those KPIs might not be something you want to look at, but maybe, there are 30,000 foot view KPIs that that your plant manager or utility director might want to just look at to get a general overall feel for how the system is going. So we build all that information into that portal and make it easy to access as long as you have a device that's connected to the internet. We have around 900 or so references globally using the Aquavista portal. But again, the main point here is about being able to serve you as best as possible. And we think the portal helps us do that. But the services that we provide, the portal it's not a necessary component of, but it does ease the functions. So just an example, any kind of documents you have, whether it's, as long as they're electronic, if they're not already electronic, they could be scanned in and put in. Those are there, available. If you're out at a piece of equipment and you need to pull up an O&M manual and you have a tablet, you can quickly and easily just pull that up there. So document storage. A big part of it is just trying to get all this information in one spot and make it as easy as possible to access. There's also the ability to track maintenance tasks and assign maintenance tasks. With this, we're not trying to be a full-blown asset management program. There are all kinds of very elaborate software solutions for that. But if you don't have one of those types of systems and you want to do better for managing tasks at your facility, there's a good tool inside the Vista portal that would enable you to do that. Instructional videos, those are very, very handy, very useful as an operator to see and watch how this is being done. We continue to grow our library of instructional videos, specifically related to Actiflo. I would say the number of videos across all of our technologies, of which there's more than 350 individual technologies we do. There's probably more resources out there for Actiflo than anything else. So it's very handy and convenient to be able to pull those up and watch those whenever you need them. And then finally, I just want to mention another solution in the Aquavista line of digital solutions, which is really focused on collection systems and more biological treatment. So if you're a wastewater plant, Actiflo, you certainly have, I would assume, some form of secondary activated sludge at your plant. Aquavista plant is a advanced model predictive based solution for optimizing all kinds of areas at your facility. It's well proven. These algorithms have been developed and perfected over more than 25 years. And in the last 2 to 3 years, it's been brought into the cloud, which makes it easier to deliver. There's a growing library of modules. So there's, for example, a nitrogen module. There is a StormFlex module. The StormFlex module fully controls, there's a SewerFlex as a part of that. Fully controls the sewer system, controls how flow is received at the plant, where flows are, how pumps operate in the collection system, based on a variety of inputs, including weather radar data, to really prepare for storms and be proactive. And again, it's all the stuff behind it, very elaborate algorithms that we've developed over 25 years and employed successfully in many small and, as you can see on the screen, very large facilities up to 1 million population equivalent and more. And with that, I will hand it back, I think, to Jill, who will help field any questions we might have had.
Yeah, thank you guys for that very informative presentation. We did have some questions that came through, but I do want to remind you while I am going through those that feel free to type any questions that you may think of as well over at the right side of your panel. So with that, I will open up the Q&A session here. Question on if the coagulation mixer was to fail, could we still operate the Actiflo?
So I'll take this as best I can. Yeah, yes. Typically, that's one of the 2 mixers that it's clearly not optimal, and it depends on how much contact time you have with your coagulant or whatever reagent. It is upstream. So I think as far as your functional description or whatever is concerned, the answer would be yes, but you probably have to compensate in some way.
Okay, another question is, we usually get around 1 to 2 grams per liter of sand. We find it very difficult to get over 2 grams per liter without all the sand going over the collectors. Are all Actiflos supposed to get that high of a concentration, or were some designed for less?
It depends on your chemistry. If you don't have much, you don't have many constituents or solids in your raw water, or perhaps you don't just have that much coagulation, then that's still a surprisingly low number. Honestly, yeah, that's surprisingly low. But I would love to know where that number came from as well, and how many samples they had taken, and kind of what's going on in the bottom of that settling tank. That is a little bit of that is a very, very low number.
Okay, and another question on just confirming that they should sample sand at the discharge of the hydrocyclone, if that's correct.
No, that's grabbing it at the underflow is one of those. If you remember the calculation, there were two sand calculations in each of the boxes that I had. One is for the underflow, and then you multiply the time that you had grabbed it, and that you have that number that you have for the underflow is going to be a different flow rate that you calculate. You also grab it at the inlet to the hydrocyclone, and that's the more basic, because then you could use the whole, whatever it is, 34 meters cubed per hour, 34 or 80 GPM inlet to the hydrocyclone calculation. So there are two places, but if you grab it from the underflow of the hydrocyclone, you have a better idea of how that centrifuge inside the cyclone is working.
Great. Another question regarding microsand, or expected microsand loss, I should say, is what is the typical microsand loss that you expect per cubic meter of treated water?
Kilogram?
Sure.
That's a lot, but yeah, that's a lot, but that's about it.
Okay. Question on specific possible online training for operation of your specific Actiflo plant, if that's available for individual plants as well, with the specifics for their plant design.
Oh man, that would be my pleasure. It's hard for me to kind of go global and go to higher level talk. I much prefer to talk to people and have them ask questions back at me on each slide, if not every section. And I love putting the numbers in for what they should actually have, rather than talking huge ranges. And I could, yeah, the seasonal fluctuations that they're seeing, their particular downstream equipment, things like that. Yeah, I would much prefer.
Yeah, this is Mark here. I want to just weigh in on that too. So we, with the Aquavista Assist package, not necessarily with the cloud, but one of the things that we do a lot of with those service contracts that we provide is training. And we have some basic standard packages that would include maybe 2 training events a year, maybe 1 field visit, so much time with use of the augmented reality tool, 24/7 phone support. So we have standard basic packages that include that, but we also can customize anything just to really fit your needs. So we do a lot of that training, whether it's to re-educate operators, or maybe you've had a lot of turnover. That is something we certainly see a lot of out there. happening a lot of in recent years is a lot of turnover of staff at plants, a lot of really experienced people retiring and moving on, and a lot of newer people coming in. And so we're certainly here to help from a training aspect.
Okay, another question is, could air scour cleaning system be installed on an existing installation? And then when would you recommend to install such a system?
Yeah, that's a resounding yes. I have seen only a few air scours go in with new units. Well, a few, maybe 10, but the most of them are retrofits. Yeah. When would they go in? You don't need a shutdown maintenance, except for maybe a day to do that. Because I wouldn't put your old lamella pack back on top of it, is all.
Okay, another question is regarding how the settling rate is calculated.
Well, the settling rate depends on if it's a package plant or if it's an as-built capital project. That really depends on the expected throughput and as well the size of your chambers.
Great. A question for Mark that came in regarding Aqua Vista. Does the Aqua Vista Assist have cloud data backup?
That is a good question. I'm not as knowledgeable about, the IT side of things and exactly what level of backup there is. I am certain that there is, but if we can get the person who asked that a question to me offline, I can get specifics on that.
Okay. A question on rise rate. Is there a minimum rise rate that you can operate? And if so, how is that calculated?
Yeah, that would depend on your proportion of the recirculation pump. Like I said before, you don't want too much of that of your throughput to be going through your recirculation pump. So it depends on the size of your plant, and that the rise rate will affect the settling and everything else. So there definitely is a minimum.
Okay, I've got some questions regarding cleaning. How often should the lamella plates be cleaned?
Once a week is a huge ballpark. It depends on how much solid and chemical reagent you have adding to the system, but I guess that's my best ballpark answer.
Okay, question on, do you have experience with the removal of iron and manganese?
Yes. Yeah, that's a pretty easy one. That's very easy to coagulate.
Okay, a question on, should the agitation speed be varied depending upon flow rate or other conditions?
I know that it can be, but I'm gonna just off the cuff say no. I know people disagree with me, especially, but I think decreasing that during times of really low turbidity and low flow can help to save energy, but no is going to be my answer. That wouldn't be my top even 10 thing to do to save energy.
Okay, Actiflo is optimized NTU wise. Our filter life is a continuous issue. Where should we start?
I would start with polymer, optimizing polymer. See if there's something you could do there, but seeing what is carrying over. Is it creating mud balls is like, why is the filter life running? Or is it something that's in the raw water that's causing the filter life? Or are you carrying over sand? It wouldn't really affect the filter life, but what is the sand carrying with it?
Okay, a question here that came in. Why do we get erratic or choppy turbidity at flow rates through the Actiflo, let's see, less than, or I'm sorry, greater than 7,000 GPM?
So,
I'm sorry, that should be less than, but yeah.
Yeah, that would make more sense. That is probably, wow, that's still quite a good throughput. So if I would love to know what your circulation pump flow rate is, and I would like to know how your rake is doing. If there's something going on, if it's not squeegeeing the best it could, and when the last time your lamella had been cleaned. There also could be something in the corners of your maturation tank. But I guess those are 4 answers. Sorry, I couldn't give you one specifically, but yeah, if you could contact either of those people at the bottom left of the screen, they can kick you to me. I'm happy, ryan.colley@veolia.com. I'm happy to find out why and give you one answer.
Okay, bear with me as I'm reading through these questions. They keep coming in here, so I'm trying not to repeat any questions, so I do apologize if I ask something similar here as well.
I'll bear with you.
A question is, we have approximately 300 hardness in our groundwater. Would this mitigate the hardness problem?
Mitigate. I don't know about mitigating hardness problem. There's a lot we could do with that. Yeah.
Yeah, I can add to that. I mean, with the Actiflo soft version of Actiflo, yes, that's exactly what it's designed for, is removing hardness out of the raw water and groundwater. So 300 parts of hardness, yeah, we could get. I want to say off the top of my head, I think we can definitely get that down to close to less than 50, probably less than 30 milligrams per liter hardness.
Okay. Question, do you have references of Actiflo carb handling TOC issues? And also, can it be retrofitted on existing plants?
I'll answer that. Yes, we do have Actiflo carb installations treating high TOC water. And as far as retrofitting, we can definitely look at retrofitting a carb tank in front of it. There would be some additional modifications to your train, mainly in the recirculation rate and a couple other things regarding the pack contact tank, but it is definitely something that we could look at doing.
I definitely agree. That's how I would do it too. There isn't yeah, adding things upstream into the sludge loop extension of that is where you would have to change things the most, and the addition system of pack.
Okay, if mixer speeds are not where we should be looking for energy savings, what would you recommend instead?
Yeah, for energy savings, if you do, well, for cost savings, I would do more lamella cleanings to reduce your reagent costs. Is definitely a big place I would go with that. And also just outright optimization. There are different ways of preparing your, say if it's a dry polymer, that takes a lot of pressure and a lot of driving there of the automation. And I know that the mixers are running all the time, but we do have more HP elsewhere along the mechanical train as well. But there are whole branches of Veolia that are into the LEED certifications and things like that, where we can reduce costs and improve how green your building is altogether.
This is Mark here. I would like to just weigh in and note that I do think that using digital tools and having better, more ready access to information will help in energy savings overall. And there are some pretty exciting new things on the horizon in terms of Actiflo and digital tools and how we can best optimize and operate those. So I don't have anything specific along those lines to share today, but in the coming months, hopefully you will see some pretty new and interesting things that might pique your curiosity.
Yeah, most energy savings and cost saving measures start with an audit and comparing one to the other. They're pretty general.
Great. Another question. As sludge and sand is directed back to the hydrocyclones, is that fixed flow rate desirable when flow through the Actiflo is different?
Yes, because of the way the centrifugal forces of the hydrocyclone operate. If you change the flow, you're going to have to change the not hydraulics, but the that veil inside the hydrocyclone as well. So bigger pump, you're going to have a bigger hydrocyclone.
Okay, a question on what is the optimal pH for an aluminum-based coagulant?
Aluminum is fairly neutral. It depends if it's aluminum sulfate or ACH. A little bit above neutral.
Also a question regarding pH control, asking just if Veolia has any pH control equipment that they sell as well.
Oh, definitely. Yeah, both lime, sodium hydroxide, sodium bisulfite, whether it's just pH or alkalinity as well. That's they're in a lot of the package, not the package. They're in a lot of the capital projects.
How does dirty lamella increase your reagent use?
You're going to have to add more sand because you're going to, by the sand grabbing or sticking onto the lamella, and then with any change in flow being sloughed off into the clarified effluent, you're going to have to add more sand to get it into the maturation tank and then the sludge loop. But whenever you have things flowing into your clarified effluent, you're going to probably be increasing dosage to try and precipitate more of that out, because you don't know that necessarily that's where it's coming from. All you see is an increase in turbidity or something else in your clarified effluent.
Let's see. Have you had any plants use streaming current meters to assist with coagulant dosing?
Yes. Yep. My colleague Marianne Dufla gave me a lot of information on that. I haven't done it myself, but I know Marianne started it up, and Felix, who was in my department as well, gave me a lot of information on that. But maybe Brian or Mark do, because I can't speak to that myself, but I know that yes, they do.
Yes, and I know over in the States we have several plants that use the streaming current. It helps them reduce coagulant dosage, keeps them from overdosing. So yeah, it's a great optimization tool.
Okay, another question that came in here is, are there any changes on the way to optimize the hydrocyclone process so that it doesn't waste so much water? In a small plant, this can be a significant volume.
Hydrocyclone so it doesn't waste as much water. So there are different models of hydrocyclone, but typically for higher turbidity that use service water and then recycle it to the, and that water is added to the process chain of the Actiflo. But I'm assuming they mean out of a more thick sludge. Is that what they mean? We do have a process where the sludge chain is put into a second loop. It's the HCS. Brian, you might be able to take this better than I, but the idea of the HCS is to take that sludge and inject it back into the sludge loop to either increase or either tack back the concentration of your sludge. I'm not sure that's what you mean by decrease the water consumption, but yeah, there's an HCS model of Actiflo that can increase how thick the sludge is.
That's correct, Ryan. You can HCS is basically an external solids loop. So the way it works is, you're drawing off the bottom of the settling tank with your sand recirculation pump, and the pump is pumping to your cyclone, and the overflow of the cyclone, a portion of it is actually routed back down to the scraper pit where the inlet of the sand recirculation pump is, and then the other part of it is wasted. In doing that, you basically create a more of a thickened solids loop and can reduce the volume of sludge that actually gets put out, which will in turn make it thicker.
Okay, a question here is, how frequently is entry into the settling chamber required to remove stubborn accumulated sand and sludge? And then, is there a reason that sludge and sand buildup would occur?
General rule, I would either by effect of what you see in your process, if there's some suspicion you have. But if everything's clear, no more than once a year should you have to do a shutdown entry. And if everything is ideal, the only thing you need to look at is, and you have like an automated air scour and everything, you have no reason to doubt how healthy your styrene is in your lamella pack. Even more than that, 3 years. But just total offhand once a year, and it might help you identify these problems. And building up in the corners will either happen because of the plugging in different cells in that honeycomb of the lamella pack, or if it's an old style maturation chamber, it can build up in the corners there if you don't have a draft tube in the middle to help with get rid of those dead zones. So the answer are dead zones that we didn't intend upon whenever we designed the project.
Okay, here's one on if lamella tubes need replacing, would you recommend switching to plates?
I would need to ask about that. I'm not sure. I don't think so, but I would definitely put the question to a design. Mm-hmm.
Yeah, I'll add to that, Ryan. I would say if your tubes have been operating fine, and if they come to like their end of life service and you're looking to replace them, I probably wouldn't replace it with plates. I would continue on with the tubes. Mainly, one reason is cost, and secondly, you do run into some issues where the supports will have to change, and that can sometimes be problematic. But it would probably be a case by case basis, but I would say just sheer cost between the plates and the tubes, you would probably stick with the tubes if they've been operating successfully.
And even if you are worried, if you haven't had great, even if you had something go wrong with your last tube settler, there are higher grade or a higher weight polystyrene to put in there. Don't automatically change the design, maybe optimize it.
Okay, what is the best method to keep the sand dropping down to the pumps?
To have the best settling, you really need to keep that process triangle of coagulant, polymer, and sand all in the right zone, and your process history will bear that out. But there are a few different ways. Maybe I can get some more specifics if this person wants to specify why their sand isn't settling like they think it should.
Okay, and another question regarding settling. Why does the sand settle out in the maturation tank during low raw water turbidity periods? And how can you prevent this?
It depends how low your raw water turbidity is, but you would end up with free sand in your maturation chamber if there just aren't that many solids or hydroxide flock to get it to turn it into the ballasted flock. It's not ideal. There are, for some reason, that there are dead zones in that maturation chamber. I'd be curious if it's a package or a design, like a large concrete project. So yeah, if it's a very low turbidity, that will also drive the amount of sand you need to have as a target concentration in your system. And also, I'd be curious to know what kind of sand you use and how old maybe it is.
Okay, here's another one that came in here. This person, they say that they have 2 Actiflo trains designed for 50 million liters per day each. Average daily flow is 35 million liters per day. They run both trains at a minimal flow rate of 17 million liters per day. We do see pulsation at the troughs. We have also consistently low sand concentration between 1 to 2 grams per liter. Could running at such a low flow rate result in low sand concentrations and the inability to increase sand concentration?
So less throughput through your system will, I guess, to go back to the last question, be another reason why you would have settling. You would find free sand in your maturation chamber. You just don't have that natural mixing that we count on whenever we set that design flow rate. So it sounds like this person has really low flow, really low turbidity, and very low dosage of all of the reagents, including sand. So that's a tough place to try and operate. I would assume the water is also pretty cold as well. When it gets colder, the water is more viscous and it's more likely to carry the sand up through the lamella pack and into the trough. So that is a circumstance that I would really like to see with my eyes. And so whether it's through maybe a digital access or hopefully one of these days, not too distant future, to actually see out there, it would be a curious thing for me to shoot.
Okay, this question that came in, they're mentioning that they're getting only 4 to 5 hours out of backwash, and they want to know possibly what could be causing that.
That's really unfortunate. So the first place I would go is to polymer. Perhaps there needs to be an intercoagulation to destroy any carryover polymer. Other than that, keeping the lamella clean is going to help you to help to decrease some of those carryover through and the buildup that gets on the lamella. I'd also like to know what the media is as well, if there has been maybe a biological issue in this filter. I know it's typical, and sometimes you need a chlorine shock. That's unfortunate. I would like to know more.
Yeah, Ryan, and to add to that, you mentioned the filter aid. Also, too, we've experienced some plants where they will try and operate and get as low a turbidity as possible out of the Actiflo, where you're using more chemicals, you're using more polymer, more coagulant, and thus what happens is they do begin to see lower filter runs just because they're trying to have such clean water coming out of the Actiflo, but really, if you're at a 1.5 to 2 NTU, which is what we've seen, the filters can typically handle that, and you do tend to get longer filter runs. Maybe don't go up quite as high as a 2, but if you're spitting out or shooting for less than 1 NTU out of your Actiflo, maybe let it go up above 1 to 1.5 perhaps, and see how the filters respond. That's something else to look at.
Great. A question regarding Aquavista that came in from Mark here as well. If we are using the Aquavista portal, does that get updated sometimes with new features? And also, do you have to pay for those updates?
Okay, I think I heard all of that. Question was about updates for the portal. So one of the nice features of being a cloud-based platform is updates are very simple and easy to deliver globally. Those, yes, as new features are developed for that, for the Aquavista portal, those are delivered to the existing customers. So there isn't currently any additional charge to get updates or receive the new features. If you're a portal customer and we implement something else that is going to be useful, and we update it to everybody, you get that.
Great, thanks, Mark. Well, looking through, I believe we've hit most of the questions that have come in here. If we did somehow miss your questions, I do apologize for that. We will follow up with you directly with that, just in case we did miss anything through here. And then there has been a question as well, if this webinar was recorded and if you will get a copy of that. And the answer is yes, we are recording this, so you should receive a copy here probably within the next day or so. So just wanted to let you know that. And then we do ask again that if you would please take the survey at the conclusion of today's webinar. That would be greatly appreciated. And for those of you who do complete that survey, you will be entered into a drawing for that $25 gift card. So with that, this will conclude today's webinar, and we do thank you for all of your time today. Thank you, guys.
Thank you.